In this lecture, we're going to look at energy flow in an ecosystem. In order to do that, first we have to define what is an ecosystem. An ecosystem is an ecological system that consists of a living community and all of the physical aspects of its habitat. Physical factors are also known as abiotic factors or non-living factors and can include light, temperature, precipitation, soil type, and any other abiotic or non-living factor that you think of that can affect a living community. The members of the living community are known as the biotic factors or living parts in an ecosystem. The biotic and abiotic factors in an ecosystem coexist. Ecosystems all rely on energy. The amount of energy available in an ecosystem determines how many organisms can live in that ecosystem. Take a look at these two ecosystems that you see here. The amount of energy input into the ecosystem determines how many organisms can live there. So where does the energy come from for an ecosystem? First, we have to start with the obvious, sunlight. It's the primary source of energy for most, but not all, ecosystems on Earth. No sun, no energy. No energy, no life. No life, big bummer. Sunlight needs to be converted in order to be used in an ecosystem. So how does that happen? Plants, algae, and some bacteria are able to convert sunlight into a usable energy source. Organisms that do this are known as producers because they produce usable energy. How do they do that? The word that we've talked about a whole lot this year, photosynthesis. So why is photosynthesis important? It traps the sun's energy and stores it into a sugar called glucose. The stored energy can then be used by living things. Here's the overall equation for photosynthesis. This is the chemical equation. We talked about it earlier in the year. You should know for the AP Biology exam specifically what happens at each step in photosynthesis. So who uses that energy that gets trapped by producers in the form of glucose? Well, we do. All living things use the energy trapped there. Producers also use this energy themselves to live. Other things that use the energy are called consumers, and we eat producers to get that energy. When we break down the glucose and thus the energy stored in it, we are using a process called cellular respiration. If you take a look at the chemical equation for cellular respiration, then you're looking at exactly the opposite of photosynthesis. There are different types of consumers. Herbivores are consumers that eat plants only. Carnivores are consumers that eat animals or meat only. And omnivores eat both plant and animals. Which one are you? Like I mentioned before, photosynthesis is the process where a producer traps the sunlight's energy and makes it into glucose, which is then stored in that producer for use by consumers. Consumers then break down that glucose and get the energy out of it by a process called cellular respiration. Again, note, the two are exactly the opposite of each other. The products of the process of one are the reactants of the other. Biotic factors, or the living part of the ecosystem, can be divided into feeding levels, also called trophic levels. You have the bottom, or first level, called primary producers. Those are also called autotrophs because they make their own food. An example of primary producer would be a plant like grass. The next level up this pyramid is called a primary consumer. These are generally herbivores, which are plant eaters, for example, cow. Secondary consumer are carnivores. Carnivores eat the herbivores from the primary level. Tertiary consumers are also carnivores. They're carnivores that eat smaller carnivores. You can also have a fourth level. Detritivores or decomposers are vital parts of an ecosystem, and they recycle non-living materials from dead organisms. Without them, life would stop. So let's take a look at the energy pyramid. You see here the levels that we talked about before. Remember, they're trophic or feeding levels. At the bottom you've got the producers. Then as you go up you've got primary and secondary and tertiary consumers. Also notice how as you go up the pyramid the levels get smaller. We're going to talk about why that is in just a second. Here's an example of what you can find at each of those levels. In this particular ecosystem you've got grass on the bottom as the producer. You've got an herbivore like a mouse as a primary consumer. You have a carnivore like a snake as a primary, or as a secondary consumer, I apologize. And for your top or tertiary consumer, you also have a carnivore, and in this case it is a hawk. Now your fourth trophic level is kind of this little pyramid over here all by itself on the left side. These are your decomposers, okay? Abiotic nutrients from the biotic factors all make it over to this fourth trophic level of decomposer. The decomposers turn those nutrients into something that can be used again and then make them available for the ecosystem once more. So let's look at how efficient our ecology or ecosystem is. Here's another example of an energy pyramid, but notice what happens to the energy as you go up the levels or trophic levels in the pyramid. 90% of the energy available from the beginning is lost as it's transferred to the next level. So the energy is lost as heat. We use that energy to continue to survive. Only 10% of the energy from each level is passed on to the next level. How energy efficient do you think that is? Let's look at a very simple food chain, and a food chain, as you should know, is the path of energy through the trophic levels of an ecosystem. All food chains begin with a producer, no matter what ecosystem you're talking about. A food web is a little more complex. It's a series of multiple interconnected food chains. Take a look at your food web. Now let's go back and look at your food chain. A food chain is linear, shows one way in which energy moves up an ecosystem. A food web is more complex and it shows multiple ways in which energy can move through an ecosystem. In most ecosystems, energy doesn't flow through a simple path like we show in a food chain. Many consumers can eat at different trophic levels. Food webs are more realistic representation of the complex relationships between organisms in an ecosystem. Here's an example of a very complex food web in a mature aspen community ecosystem. You can see you have multiple different places that you could pull food webs from, but if you put all the food webs together in this community, you can see that they get very complicated. Now let's talk about productivity. Productivity is a measure of the amount of energy available in an ecosystem, and in science we like to measure things. So we can measure two types of productivity. Gross primary productivity, which is a measure of the total energy captured by plants through photosynthesis. So this would be the energy at the very bottom or beginning of that ecological pyramid. And then you have net primary productivity, which is the productivity available to the consumers of that pyramid as you move up. The difference between the amount of energy trapped by photosynthesis and the amount of energy used by plants through cellular respiration gives you your net primary productivity. So how would that look in mathematical terms? Like this. NPP is net primary productivity. GPP is gross primary productivity, which is the total amount of sun's energy trapped and converted into usable form. And then your R sub S is respiration, the amount of energy used by the plant for its own survival. Net primary productivity is important because it's the energy available to the consumers as you move up the pyramid. So how do we change net primary productivity? Well, 12% decline in net primary productivity on Earth is due to deforestation. 28% is used for food, building materials, and energy like electricity. Together, 40% of Earth's net primary productivity is already committed to the use of humans. So you have to factor that in when you're looking at an ecosystem, because we are part of our ecosystem. Want to know if you paid attention well enough? Take a look at these vocabulary terms. If you can answer them and discuss them, then you're well on your way to knowing about energy in an ecosystem. 2 questions for you. Most food chains only have 4 levels. Why is that? If you can't answer that question, go back and take a look. Number 2, use your knowledge of energy flow through an ecosystem to explain why we could feed more of the Earth's people by eliminating meat from our diet.